In this video, we're going to talk about average rate of change, specifically with exponentials in this unit, but it can apply to any function. Average rate of change, you're given this on your formula sheet. It kind of says it in words. It says the change in the y value divided by the change in the x value, which is change in y over change in x, for two distinct points on a graph. So you just have to have 2 points, and basically all you're finding is the slope between those points. So if you want, you can just use the slope formula, y2 minus y1 over x2 minus x1. So for example, if I want to know the average rate of change from like here to here, the graph goes up a little and then down a lot and then up even more, but on average, all you have to do is find the slope between these 2 points and it'll give you the average rate at which it changed over that interval. So this would be the point 5, 5, and this is the point -1, 2. And so the rise, or the change in y, would be up 1, 2, 3, and then the run is 1, 2, 3, 4, 5, 6. So you go up 3 over 6, which simplifies to a half. So even though this graph kind of is bumpy, it averages going up 1/2 each increment of x, as you can see. Let's try it with another graph that's more exponential. Find the average rate of change on the interval -3, -1, and then -1 to 1. Remember that these intervals are x values. So this goes from where x is -3 to where x is -1, and then this is from -1 to 1. Notice, since it's exponential, -3 to -1 is significantly steeper than -1 to 1 is. So I would expect this one to be a bigger negative number, or I guess smaller, but it's going to be a bigger number than this one is. This is less of a negative average rate of change. So let's actually calculate this. So this is the point -3, 8, and this is the point oh no, I want to go to -1. So -1, 2. So I'm basically just finding the slope of this line. Like, it starts off steep, but then it's a little less steep, but on average, it goes down 6 and over 2. So down 6 over 2, which simplifies to -3 on that interval. For this interval, I'm going from -1 to 1, and I'm not sure exactly what this point is. It looks like it's about 1 and then like a half, but I'm gonna actually use the function here. So if I plug in 1, what do I get out? So 1/2 to the first power, plugging in a 1 here, is 1/2. So yeah, it is a half. Okay, on this one we go down 1.5 or 1.5. So down 1.5, and we go over 2. If you divide 1.5 by 2, you get -0.75. So like I said, see how this one is a much smaller decrease? This one is a much bigger decrease because it's steeper than this right here. And then it would continue to get smaller and smaller as we go because it's exponential. Or if we went that way, it would continue to get steeper and steeper. All right, so let's try one more. This one doesn't give us the graph, it just gives us an equation. You could graph it in your calculator or by hand, but I could also just plug in these values, because if I want the rate of change, again, that's just slope. So it's y2 minus y1 over x2 minus x1. I have the x's, but I don't have the y's that go with them. So to find the y's, just put it in your equation. So if I put in -1, 2 times 3 to the -1 plus 1 is, follow order of operations. So do -1 plus 1 first, which is 0. And then do exponents. 3 to the 0 is 1. And then 2 times 1 is 2. So when I put in -1, I got out 2. When I put in -1, I got out 2. That's one of my points. Now let's put in a 2 for x and see what happens. So 2 times 3 with a 2 plus 1 power. 2 plus 1 is 3. 3 cubed is 27. And 2 times 27 is 54. So when I put in 2, I got out 54. Now that I have my 2 points, I can find the slope in between them. Do y2 minus y1, so 54 minus 2, over 2 minus negative 1. So the change in y was 52, and the change in x was 3. And not quite sure what that is. 52 divided by 3. It doesn't come out even, so you can just leave it like this. Or if you want to make it a decimal, it's 17.3 repeating. So either way. This tells me that on that interval, the graph probably was increasing by a little bit and then a lot of it, but on average it was pretty steep and positive. It was going up by 17.3 for each increase of x. And that is the end of this lesson.